Okay, so let's go with a more detailed calculation here, more of a typical calculation. Maybe you've got 5 grams of nitrogen gas and you react it with 4 grams of hydrogen gas. And the question is, how many grams of ammonia gas do we make? And in order to answer this problem, we need to have the balanced chemical equation. So nitrogen plus 3 hydrogen goes to 2 ammonias. I'll just go ahead and balance that real fast. And how are we going to do that? So we have to kind of do this as kind of the mole city approach, right? So down here we've got grams, and up here we've got moles, and we can't go from grams to grams. So we're going to have to do this in 2 different steps. So in red, we're going to take our 5 grams of nitrogen, and we're going to convert that to moles of nitrogen, and then we're going to convert it to moles of ammonia, and then we're going to go down to grams of ammonia. So that's a 3-step process. So step 1, we'll need the molar mass of nitrogen. Step 2, we need the coefficients. And step 3, we need the molar mass of ammonia. And then we're going to compare that to the other approach, right? Which is where we start with 4 grams of hydrogen. Okay, and again, we've got to take it up to the number of moles of hydrogen in step 1, and then we take it to the number of moles of ammonia, and then we take it to the number of grams of ammonia. So we have to do this problem essentially twice and compare notes. So how are we going to do that? So we're going to take each one and convert. So 5 grams of nitrogen. We need the molar mass, so we can go ahead and add up the mass of 2 nitrogens. It is 28.02 grams per mole, I believe. Something like that. Anyway, and that's step 1. So now we need to convert it from moles of nitrogen to moles of ammonia. They're in a 1:2 ratio. So we're going to say that for every 1 mole of nitrogen that goes in, 2 moles of ammonia come out. And then step 3, right, we're going to need to convert moles of ammonia to grams of ammonia. Don't let the coefficient fool you there, right? It doesn't matter that there's 2 of them there. We just need to know the mass of 1 ammonia. So we add up a nitrogen and we add up 3 hydrogens, and that gives us the mass in grams of a mole. And you should be able to do this and come up with something like 17.03 grams. So once we do that, we get the predicted mass of ammonia, and that is 6.1 to 2 significant figures grams of ammonia. Is that the right answer? Not sure. Now we're going to do the exact same thing for the hydrogen. So we got to take our hydrogen and we got to convert it to moles. And so we add up the weight of 2 atoms of hydrogen. That's 2.016 grams per mole. Okay, that's step number 1. That gets us up to here. And then we see it's a 3:2 ratio. So we just say that 3 moles of hydrogen make 2 moles of ammonia. Okay, and then the very last step is we convert the moles of ammonia to grams of ammonia. So we just add up the mass of a nitrogen and 3 hydrogens. So we don't worry about the 2 in the balanced equation because the coefficient in this step here takes care of that. So we just want to know the molar mass of 1 mole of ammonia. And actually we can kind of cheat and just look on the line above. And once we do that, then we should see everything canceling. So actually, let's see, grams, hydrogen, moles, ammonia. So that gives us grams of ammonia, and I get 23 to 2 significant figures grams of ammonia. So the question is, how much do we actually make? And the answer is it's always the smaller amount. Why? Because after we've made 6.1 grams of ammonia, we've used up all the nitrogen. So even though the hydrogen had the capability of making 23 grams, we ran out of the nitrogen first. So it's just like the cheese slices and the bits of bread, right? Once you run out of the bread, it doesn't matter how much cheese you've got, you can't make those other sandwiches. So the nitrogen then is the limiting reactant, and the hydrogen is the excess reagent. And just for fun, right, we should be able to go backwards and tell how many grams of hydrogen is remaining. So let's have a go at that. So how do we do that? Well, we can go ahead and we can take our 6.1 grams of ammonia, which, by the way, that is what we call the theoretical yield. So this is how much in theory we make, and we can convert it back to hydrogen. We can say, okay, well, grams of ammonia to moles of ammonia, we know there's 17.03 grams in a mole. So we're kind of going backwards. And then we can say every mole of ammonia makes 3 moles of hydrogen. and then our mole of hydrogen weighs 2.016 grams of hydrogen. So essentially we're doing this calculation kind of backwards. So we're kind of converting backwards. So we're taking our 6.1 grams of ammonia, we're converting to grams of ammonia, and then moles of ammonia, and then moles of hydrogen, and then grams of hydrogen, something like that anyway. So if we go ahead and we calculate that to two significant figures, we get 2.2 grams of hydrogen. So if we started with 4 grams of hydrogen and we used up 2.2 grams of hydrogen, then presumably we must have had 1.8 grams of hydrogen remaining. So at the end of the day, we would have remaining hydrogen. This is a huge problem in your car, right? So your car squirts gasoline and air into the cylinder, and you really want to make sure that you don't have any gasoline left over. You want to make sure that gasoline is your limiting reactant. It doesn't matter if there's a little bit of air or a little bit of oxygen left over, although maybe it's a little wasteful, or maybe you want to assume complete combustion. But definitely in this problem here, it would be a definite challenge to have leftover hydrogen, because hydrogen is actually kind of expensive. So when they make ammonia, they want to make sure you're always in a situation where that expensive hydrogen is completely used up. We don't want it left over. Thanks. All right, so if you're happy, you can skip this part, but if not, here's a problem for you to try. So let's take the reaction between hydrogen and oxygen, and maybe we have 8 grams of hydrogen reacting with, say, I don't know, 2 grams of oxygen. And the question is, how many grams of water can you make? And what's the limiting reactant and what's the excess reactant? So go ahead and pause the video and give this a whirl, and then unpause it when you're ready for me to go through the answer, okay? All right, so let's have a go at this one. So we're really going to break this down into 2 problems, right? We're going to take the 8 grams of hydrogen, and we're going to say, how much can we make out of that? So 8 grams of hydrogen, we're going to convert to moles. So we know that there are 2.016 grams of hydrogen in a mole. We just add up the weights of 2 hydrogens. We can see that for every 2 hydrogens, we make 2 waters. So we can do a 2 to 2 conversion. So 2 moles of hydrogen make 2 moles of water. And then we need the molar mass of water. We know that 1 mole of water weighs 18.02 grams of water. So you just have to add up the weights of 2 hydrogens and 2 oxygens. And that gives you your predicted amount. And I get 71.5, so 72 grams of water. And then we do exactly the same thing for the oxygen. So we go ahead and we take the oxygen, and there's 2 grams of oxygen, and we convert it to moles. So 32.00 grams of oxygen in a mole of oxygen. We just add up the weights of 2 O's. And then we go ahead and we notice that in our balanced equation, 1 oxygen makes 2 waters. So we can write 1 mole of O2 on the bottom and 2 moles of water on the top. And I guess we've been a little bit naughty, right? We should probably cancel our units. And now we got moles of water, and we just need to convert that into grams. And we can kind of cheat and look on the line above, or we can refigure it out. 1 mole of water weighs 18.02 grams. Again, we're just adding up 2 H's and an O. And if we do all of that, we get 2.3 grams of water. So clearly we can't have 2 different answers. So we go by the smaller. So essentially the oxygen is the limiting reactant. When it's all used up, it can only make 2.3 grams of water. And that means that the hydrogen is the excess reagent. And if you want a little bit of a challenge, okay, you should figure out how much hydrogen is remaining, and pause the video and figure it out, and then unpause it, and I'll actually just tell you the answer. Okay, pause now. Okay, and you should have got an answer of 7.7 grams of hydrogen remaining. So we've only used up 0.3 of a gram, so there's 7.7 left. So how did I do that? I took the grams of water and I converted it into moles of water, and then I converted it into moles of hydrogen, and then I converted it into grams of hydrogen. And that told me how much was needed to make that much water. And then I figured out I only needed something like 0.3 grams of hydrogen to make 2.3 grams of water. And I subtracted my 0.3 away from my 8 to get 7.7. And if you got that, very good. That's quite a tough problem, actually.